Hello, we are continuing factoring, and we're going to look at factoring things that have a lead coefficient other than 1. So we're going to have a number in front of the x squared. So these first two problems, notice that we're going to be solving by factoring, so I always need to get everything on one side equal to 0. So I need to subtract the 16x first. So that gives me 2x squared minus 16x minus 66 equals 0. Now what we're going to do is, remember we talked about looking for the greatest common factor. So can I divide each of these terms by the same number? Yes, I can divide everything by 2. So I want to make sure that I keep that 2 out in front, but then that leaves me with x squared minus 8x minus 33. Okay, so this makes our job easier because now we can set up our diamond or our x and put negative 33 in top, negative 8 in the bottom. And then we're going to find our two numbers that give us, multiply to give us negative 33 and add to give us negative 8. So that's going to be 3 and negative 11. So I'm going to rewrite, so the 2's coming back down, that's still out in front, but I'm going to rewrite this trinomial as x plus 3 and x minus 11. So it's factored, but we need to solve it now. So remember when we solve, we set each factor equal to 0. So this first one, 2, if I set that equal to 0, there's no x to solve, and this doesn't even make sense. All right, so we don't have to worry about that one. It's like no solution there. X plus 3 equals 0. We can subtract the 3 and we get x equals negative 3. And then if I set x minus 11 equal to 0, then I get x equals positive 11. All right, so let's do another one like that. In this one, we had to subtract the 135 first. So I'm going to have 3x squared plus 12x minus 135, and that's equal to 0. And then I'm going to divide by the greatest common factor. So what can I divide each of those by? Well, I hope I can divide them by 3. 135 is a pretty big number, so you'll probably want to use your calculator there. So I'm going to put 3 on the outside, and then I'm going to have 1x squared plus 4x, and this actually comes out to be 45 when I divide that. So I'm going to set up my diamond, or my x factor. Negative 45 goes in the top, positive 4 goes in the bottom. And if I look at my factors of 45, I've got 1 and 45, 3 and 15, and 5 and 9. So the last ones are going to subtract to give me 4. Remember, I know I'm subtracting because the 45 is negative. So I want it to be positive 9 and negative 5, because 9 minus 5 equals 4. So now I can rewrite this. The 3 gets brought down, and I have x plus 9 times x minus 5 equals 0. And then we're going to set each of our factors equal to 0. Again, the 3, I don't really need to worry about this because the 3 is not equal to 0. That just doesn't make sense. But I have x plus 9 equal to 0, so x is equal to negative 9. And I have x minus 5 is equal to 0, so that equals x is equal to 5. All right, so now what happens if I look for a greatest common factor and either there isn't one, or I have something in front of the x squared still? So this is what I'm going to show you a method, and we're going to use the x factor like we did before, but we're going to do something first. So the first step we're going to do is we're going to multiply that first number. I'm going to call that, we know how this is like ax squared plus bx plus c. I'm going to be multiplying the a times the c number. So the first number times the last number. So if I do 2 times 5, that gives me 10. So that number is what's going to go now in the top of our x. The b, the middle number, still goes in the bottom. And now what I'm going to do is find those two side numbers just like we did before. So remember, for 10, my factors are 1 and 10 and 2 and 5. So the ones that add up to equal 11 are 1 and 10. Now the difference here is because we have that 2 in front of the x squared, I'm not going to write parentheses x plus 1, x plus 10, because that would not give me 2x squared. So instead what we're going to do is we're going to replace the middle term, the 11x, I'm going to replace that with these two side numbers. So that's what this first step says. Break the trinomial into 4 parts. Okay, so my 4 parts, I'm going to leave the 2x squared and the 5. Those stay the same. But what's going to change is instead of 11x, I'm going to split that up into 2 terms. So it's going to be plus 1x plus 10x. Okay. So look, the 2x squared and the 5 stayed exactly the same, and the 11x became 1x and 10x. And why would we want to do that? Remember, we're trying to go backwards in the FOIL process. So reminder over here, this is just some side work. If I had x plus 3x minus 5, and I FOIL that out, I would get x squared minus 5x plus 3x minus 15. So when I FOIL, I get 2 middle terms, and then we combine those like terms to equal 1 single middle term. But now what I'm doing is I'm going back this way, right? I want to take my single middle term and figure out what 2 things that I combine to get that middle term. Okay, so that's what we just did here. The 11x is getting split into 1x and 10x. Now, this is going to be just like factoring by grouping that we did in the last video. So that's what this step is saying. Group the result into 2 chunks. So I'm going to have the first 2 and the last 2. And then I'm going to do the GCF twice. So the greatest common factor in this first one is simply x. So I'm going to have x parentheses 2x plus 1. In this second set of parentheses, I'm going to divide both of these by 5. So I'm going to have still a plus, but my 5 goes in front of the parenthesis, and then I have 2x plus 1 again. And remember from last time, we want those parentheses to be the same, right? We want to be able to divide those out. So that 2x plus 1 comes in front of the parenthesis. Those get divided out. And when I get rid of those parentheses, then I'm left with x plus 5. All right, so now I have factored that completely using the x factor. So I could check, if I wanted to check, I could FOIL that out again. That would be 2x squared plus 10x plus 1x plus 5. These combine to give me 11x, and I've checked that. Okay, so let's do some more like that, because this will take some practice. All right, so we're down here. And remember, the first thing we want to do is check for the greatest common factor. But if you look at 4 and 16 and 9, none of those numbers can be divided by any other number besides 1. So I can't do a greatest common factor, but I'm going to do the a times the c, right? So this is the a, this is the c. So when I do 4 times negative 9, that gives me negative 36. Remember, that goes in the top part of my x, and negative 16 goes in the bottom. Remember, the middle goes in the bottom. All right, so now we need to find what 2 numbers multiply to give me negative 36, add to give me negative 16. So over here, I'm going to do my factors of 36. So I've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So we want them to subtract because this 36 is negative. So which one of these pairs subtracts to give me 16, a negative 16? So this is it. And we want to do 2 minus 18 so that we get a negative 16, not the other way around. We don't want to do 18 minus 2. All right, so what do we do with the 2 and the negative 18? Well, we're going to put those in the middle, right? So 4x squared stays the same. The minus 9 stays the same. What changes is the minus 16x. So instead, I'm going to have plus 2x and minus 18x. Okay, so that's the first step, is breaking that up into 4 terms. Okay, because if we want to do first 2 and last 2, then we have to have 4 terms to do that with. All right, so the first 2, I'm going to be dividing out the GCF. That's going to give me 2x. I'm dividing both of those by 2x. So I will have 2x parentheses 2x plus 1. And then in the second set of parentheses, I'm dividing both of those by a -9. And just so you know, if you're dealing with the second parenthesis, if that first one is negative, you always want to divide by a negative number, even if the second one is not also negative. So just be aware of that. That makes your parentheses match up. So I've got a -9 that I'm factoring out, and then I would be left with positive 2x plus 1 because I'm dividing by negatives. All right, so now our parentheses match. The 2x plus 1 and the 2x plus 1. So I have 2x plus 1 in front, and then the 2x plus 9 is what's left over when I divide by the 2x plus 1. So that would be my final answer. Okay, we got one more that I want to do, and then we'll talk about how to use this to solve. All right, so again, I'm always going to check to see if there's a GCF. So I've got 6 and 12. Now there's a GCF between there, but notice this has a 1 in front of it. So I can't divide 1 by 6. So don't try to divide everything by 6 there. So because there's still a number in front of the z squared, I need to do the a times c. So I'm doing the 6 times the -12. So 6 times -12, that gives me -72. So put that in the top part of your x, and then I'm going to put 1 from the 1z down on the bottom. All right, so let's look at 72. That's kind of a big number, so you might want to list your factors. You don't have to if you already know what they are, but I'm just showing you so that you know how I'm coming up with my numbers. So remember, 72 is negative, so I want these to subtract to equal 1. So this is the only pair that subtracts to equal 1. So I'm going to put 9 minus 8. That's what gives me positive 1. So I want to make sure that 8 is negative. All right, so remember, what do? The 6z squared stays the same. The -12 stays the same. The thing that's changing is the 1z. So I'm going to have plus 9z minus 8z. And now I have my 4 terms that I can break into 2 different parts. I've got the first 2 and the last 2. So I'm dividing this first one. Let's see, 3z will go into both of those. So I have 3z parentheses 2z plus 3. In the second set, I'm going to do a negative number, and it looks like -4 is the highest I can divide both of those by. So I'm going to have -4 in front, and then I'm going to have positive 2z plus 3. Oh, I put an x. Sorry, this is a z. Okay. So now I've got 2z plus 3 in both of them, so that's going to be my parenthesis out in front. And then what I'm left over is 3z, and then make sure to put that -4 because we factored out a negative. All right, so now let's look at the bottom here. We're going to actually find the solutions. And remember that we can call these solutions or x-intercepts or roots or zeros. There's lots of terms for doing the same thing. Essentially, we are solving for x. Okay, now if we're trying to find the roots or the zeros, that means we have to set our equation equal to 0. So we're going to replace that y with a 0. But we're going to do this by factoring, so we'll do that later on. All right, so is there a GCF in this one? Nope, there's no GCF. So we're going to do a times c. So that would be 3 times -4, that's -12. So in my x, I'm going to put -12, and then in the bottom, -1. So we need to find the factors of 12 that subtract to give me -1. So I want to do 3 and 4, but I want to make sure I do 3 minus 4, not 4 minus 3. All right, so let's rewrite this, break it into 4 separate parts. So we're going to have 3x squared plus 3x minus 4x, and then the -4 stays the same. So remember, the first and the last stay exactly the same. The middle gets replaced. So group those first 2 and last 2 together. And so I'm going to divide this by 3x. So I'll put 3x in front, That leaves me with x plus 1. I'm going to divide each of these by negative 4. So I'm going to put negative 4 in front, and that leaves me with positive x plus 1, which is what I want because I want the parentheses to match. So I have x plus 1 and 3x minus 4. Now here's where, remember, normally we would be done, but we're trying to solve. So here's where we need to make sure we set this equal to 0. And this is why I wanted you to know why you set each factor equal to 0. So x plus 1 equals 0, pretty easy. That's negative 1. But if I have 3x minus 4 equals 0, you have 2 steps to do here. So I'm going to add the 4 first. So that gives me 3x equals positive 4. Then I'm going to divide by that 3. So this has 2 steps to it in order to get x equals 4/3. And don't let that fraction scare you. It's okay to have a fraction as an answer. All right, but the point is we got 2 different answers. All right, let's do one more just so we get the hang of that. So we're solving. There's no GCF, and I can't divide 2, 7, and 3 by anything. So I'm going to do a times c. 2 times 3, that gives me 6. So I'm going to put 6 in the top and negative 7 in the bottom. So I need my factors of 6. So that's 1 and 6 and 2 and 3. And this is a positive 6, so I need them to add to equal 7. Okay, but this is a negative 7, so I would need both of these to be negative. So I need negative 1 and negative 6. Remember, if this is positive, these need to be either both negative or both positive. All right, so then let's rewrite. 2x squared stays the same, plus 3 stays the same. Instead of 7x, I'm replacing it with negative 1x minus 6x. All right, so let's group the first 2 together, the last 2 together. So in this first group, I can only divide by an x. So that's going to leave me with 2x minus 1. In the second one, I'm going to divide by 3, but remember what I said, how this first one has a negative? I really want to make sure I divide by a negative 3, not a positive 3. Here's why. If I do a negative 3, then I have negative 6 divided by negative 3. That gives me a positive 2x. And then 3 divided by negative 3 is a negative 1. If I hadn't done that negative, then my parentheses would not have matched. I would have had a negative 2x and a plus 1, and then I wouldn't have worked. So I'm going to have 2x minus 1 times x minus 3, and we're setting that equal to 0. So we're going to set each parenthesis equal to 0. So 2x minus 1 equals 0, x minus 3 equals 0. In this first one, I'm going to add 1. That gives me 2x equals 1, and then divide by 2. So x equals 1/2, and that's okay to have a fraction. And then over here, we're just adding 3, so we get x equals 3. All right, that's what we do when we factor anything that has a number in front of the x squared. There are other methods as well, and I'll show you that in class if you're interested, but otherwise we'll stick with this method.